we're going to look at parameterized curves. So first of all, we're going to look at the rule, and then we're going to look at an example. So if y is some function of t and x is some different function of t, we know from our rules of derivatives that dy by dt is equal to f dash of t. That's just a notation thing, and and dx by dt, again we can write it as g dash t. The point is here is that with this we know easily how we can find the derivative of y with respect to t and the derivative of x with respect to t. Okay, we just differentiate our function with respect to t. But say, because when we're looking at parameterized curves, we're really interested in the relationship between y and x. It just so happens that we've defined x and y in terms of some other parameter. So if we want to find dy by dx, well, this turns out quite simply to be f dash of t over g dash of t. This makes sense because this is dy by dt over dx by dt. You can imagine the t's almost cancel each other out. Not really what's going on, but by chain rules and such, this does turn out to be true. Now let's look at an example. So say we define y to be equal to 3t plus 4 and x is equal to t squared. The first thing I want to find dy by dx. So I'm going to find dy by dt, well, that's just equal to 3, and dx by dt is equal to 2t. So dy by dx is equal to 3 over t. Okay, so the rate of change of y with respect to x is equal to 3 divided by 2 times this parameter t. The reason I chose t is because often a good parameter that you might get in real life situations is time. Say you know over time that one bacteria grows at a certain rate and a different bacteria, so one bacteria y grows at a certain rate and one bacteria x grows at a different rate. You might want to see the relationship between those two bacteria x and y, but you only know x and y in terms of this time parameter t. You can obviously have different parameters, it's just t tends to be the notation I choose. Now we want to write y, x and y in terms of each other, so we want to get rid of the t. So if we want to get rid of this t, then we want to rearrange in one of these equations for t. We want to use the linear equation because ideally we don't want to have squares in here. So I want to rearrange this top equation, y equals 3t plus 4 for t. So I get y minus 4 is equal to 3t, which gives t is equal to y minus 4 over 3. X is equal to t squared, but now we know t, we can write t in terms of y, so x is equal to y minus 4 squared over 9, and I'm happy to leave it like that. We've got x in terms of y, we could rearrange y in terms of x if we wanted to, although we would have, because of this square, it makes it easier just to leave it like this, which is fine. There's some relationship between x and y. So hopefully you can understand the basic concept behind this, is what I was trying to say. Yeah, if this comes up in exams, I believe they can just test you on trying to write it in this typical format, x and y, so converting between the two forms, or they can tell you to find the derivative like I've shown you here. The other thing you might have to do is model real life situations using this. So that's what we'll look at in the next video. If you do have any questions, please be sure to let me know down in the comments. But for now, that's it. If you did enjoy this video, please like and subscribe, and I hope to see you in the next one.